study hall, and then I took it home to read it. I laid on my bed doing nothing, so I finished the reading.
Okay, so we have an active ingredient that forms when swimming pool water is treated with chlorine. In addition to its oxidizing abilities, it has a relatively high affinity for protons. It is a much stronger base than Cl-. That makes sense because that's the conjugate base of what?
Strong acid.
Yep. And forms a weakly acidic hypochlorous acid. Calculate the pH of a 0.1 solution that has it in it. So, the very first thing is to probably identify what?
So it'll be a weak acid. It's a strong base, would be a weak acid.
I mean, that should tell you that's a weak acid. Also, the fact that it says weakly acidic
Oh.
might also tell you that.
And
But,
it's focusing on the
yeah.
strong.
Okay, so really we've got this guy, which is a weak acid, so that's going to be a dominant species. And then our water. Okay, step 2 is we could show the breakdown of these guys. I'm not going to do that. I'm just going to write their K values. And why do I do that?
No, that works just as well.
Because what?
It works just as well.
Okay, but what am I trying to get from looking at the K values? What? Are you sick? I thought you were just whispering to. Which one's going to be the dominant? Yep.
How do you know if they don't tell you the
They'll have to tell you the K value. Or, I mean, I guess they could say it's. I mean, they won't give you a K value for a strong acid. You'll have to identify that by the fact that it's a strong acid. But this is a constant, right? And anytime we're doing a weak acids problem, or even a weak base problem, they should give you the K value. So, which one is our dominant producer of hydrogen? And why is that?
Also, it'd be just an easy problem otherwise.
Yeah. That's not so dominant.
That's right. It's close enough.
Okay. Step 4, write the expression now that we know what the main contributor of our hydrogen is going to be. Products over reactants is going to break up into OCl- and H+. The nice table. Questions on this? So far? Any?
You say most of this would just be the square root.
Most 1 to 1.
Okay.
And if it's 0, I would worry about the process. Get the process down
Okay.
first before you worry about the shortcuts. Cool? Okay, it tells us the solution or the concentration of this. These are 0. Why is it minus and then 2 pluses? Because I have 1 and 0, or some amount and 0. Plug into our equilibrium expression. Now I'm removing this x, y. Okay, and why is a 5% test a legitimate option? Yeah, it's such a small, a small K value, which means it's a weak acid, which means this isn't going to break apart into that much, and the change is going to be small and pretty much be negligible to affect that number 0.1. So remove it. Solve. You guys figured out X yet? What is it?
It's 5.92.
Okay, we need to make sure that that is a safe approximation by doing what? Okay, it's going to be our change over our initial. And you could probably tell by this how small that X is that it's going to give you less than 5%. Everybody understand that it's change over initial concentration of your weak acid, always? When you do that, it gives you a rather small percent. That's a small percent. We're safe? And then now that we know that that is our correct X, or a sufficient approximation for X, what do we do? Negative log to get to what? And pH is? We got 3.3.
3.23. I'm trying to find you again, right?
Yeah, I don't know. Anybody else get that? Grant?
Yeah.
Gibson Brothers? Kansas Brothers? I'm sorry, calling
So
you
negative
Santa.
log of 5.92.
Every year last
That's
year.
the problem.
He,
Every day last year.
yeah, every day last year, he would just whisper something just to like bother me, because I was like, what? You got something to say or not? Ugh, drove me nuts. Anyway. Questions before we move on to the last one here? What we got? Next one's a little bit different. I mean, little is probably safe to say. A huge difference in the process, but again, what you're going to find in this chapter is each new lesson will add another little wrinkle, and so you'll just got to know what the wrinkle is, and then everything else will be very similar or the same. So on this one, what's different about this problem?
It's 2 acids.
It's technically 3.
Oh,
Now
yeah.
water, right? Now, both of those acids are not strong, so they're weak. So we know our this is close. This looks like a strong acid, doesn't it? HNO3 is the strong acid. Okay, so the guys that we have at equilibrium prominent are our 2 weak guys because they don't dissociate very much, and your water. Okay, well then we got to figure out which one is going to be the dominant producer of hydrogen ions.
Maybe the 1802.
Yeah. I wrote that down. So if you look at this, yeah, they're both weak acids, but one is a significantly stronger weak acid. This is on the higher end of strength for a weak acid. Okay? Now, on top of that, it's also more concentrated. However, I will say this, the dominant way to figure out what gives off the most hydrogens is going to be your Ka value. A little impact is the concentration, but a much bigger impact is your K value. Even if like I had 5 molar of this and 1 molar of this, I still would assume that this is probably the dominant giver of hydrogen. Okay? So what does that do then, or what assumption are we going to make?
That the other two are negligible because it's the
Yeah.
dominant.
So we can pretty much just do what to the other two?
Get rid of them or not care about them.
Ignore them. I mean, same thing you said.
Yeah. No, that was what I was trying to think of. No one.
Okay. And everything else is the same. You want to try to do this one on your own? Okay.
Sure.
Why don't you guys try to do this on your own? However, so I want you to find the pH. There is one other thing it asks for in this problem, but just find the pH, okay? And I'll go through the other parts of it.
Where do you use the coefficient? Where does the coefficient go in here?
Where are you going to have a coefficient?
No, not matter.
Talking about setting up the ice table? Okay, so I stands for initial concentration.
That's all.
And then your C would be your change, it would be your X, your minus X.
Right, I got it. I was thinking if I was a coefficient, not a concentration. So that's what I was off. Even that, I remember that now. Actually.
always use if like it's above 5%, then you just have to go back.
Like you're saying if it was more than 5%, yes, you would, yeah.
That's not.
Yeah, if it's higher than 5%, then you actually gotta go back and do the quadratic, or whatever the math suggests to do. It may not always be quadratic, it might be, cubic or something. You get 1.35? Alright, so I want to just talk then about the second part of this question, which is also calculate the concentration of your cyanide ion at equilibrium. Any ideas how to do this?
The H value is the same problem.
That would help.
Yeah. I don't know how many CNs.
You should just square root.
It won't be the same as CN. What do you say?
Square root of 6.2 times 10 to the 10.
Oh, no.
No, it won't be divided by 5.
No.
You're right, you're right.
Can't you just do an ice table for that?
You could. It's easier than that.
Just the K, not like.
You can use the K expression. Right, that would be H plus CN minus over the whole thing. Right? Don't we know this? Okay. I mean, even if we added the other two contributing factors of H plus to it, it's not going to change that number. So, what did we say that was? What was the X? 0.045 approximately, is that right? Okay, this is what we want. Whoops. Oh, I should have just done brackets. Now, do we know this? We know the initial concentration.
Actually, plus
That would be the
I.
same as H. It's very close to 1, yep. So since it's so close to 1, we can assume it's 1. Why do I say that?
Because you do 1
But X is so.
No, X is so small, right? It's a weak acid just like the other situations. So technically what you could do is you could do 1 minus 0.045. You could do that. Does that make sense? Okay, but since it's so small, you could probably just treat it
That's around 1.
as 1. So, you solve that? So yes, it's a lot of math, but you have to remember the conceptual stuff to know how to do the math. Does that make sense? Everybody? What'd you guys get?
1.39 times 10 negative. There you go.
We're done.